Hello everyone, welcome back. In today's video, I'm going to show you how you can generate realistic images. We are talking about photorealism. Let's take a look. Here's an image that you will be able to generate with the Flux.1 Dev model. It's quite nice, but as you can see, we have that AI look to the character. Now with today's model, you will be able to generate these type of images. As you can see, the person face is way better defined, and the detail in the skin, the beard, the mustache here is way better compared to this default Flux.1 Dev model. This is what we are going to explore today with this new model. Now, if we take a look at the difference map here, you can see that the main difference is on the person face. Anything that is black means it's pretty much the same. Here it's white, and that's because the background itself is different, this one here. But when we take a look at the person face here, you can see that we have a lot of white. This means that we have a lot of changes happening here. And this drastic difference that we are seeing from these two images here was achieved by making one simple change to your default workflow, that is to change the base model. Today's project is about the Tencent SRPO model, and it is a model that is designed to improve image generation, mainly in realism and aesthetic quality. I'm going to leave a link to this HuggingFace post so you can take a look at it. Now we have the abstract here, and I've written a small bullet point so that you can read at your own time. So you can pause and read it, or you can go into the page and read the abstract itself. They talk about two challenges that we have when it comes to training and fine-tuning model. The first one is about the computational expense, and that is because we are doing the gradient computation for the reward scoring at each denoising steps. So in this particular case, they explore better optimization. Then we have the issue of offline reward adaptation. They talk about that the frequency required for continuous offline adaptation for models to reach that photorealism is too expensive. And their solution to those two problems is, one is the direct align, where they try to avoid over optimization in late time steps. And they do this by trying to interpolate between the noise and the target images. And then the second one is the SRPO, which is semantic relative preference optimization. And instead of doing an offline adaptation, they are now doing an online adjustment through positive and negative prompt augmentation. And through this study, they found out that by tuning the Flux.1 Dev model using these two methods, they were able to get a 3x improvement in terms of human evaluated realism and aesthetic quality. So we're talking about photorealism. Now I'm going to scroll through. You can pause and read everything at your own time. So today's model focuses on enhancing realism in your images. You can use it for any portrait, any character generation. You can also use it for landscape. So here are a few examples I've generated using this model. So as you can see here, we have a portrait of a woman, and take a look at the skin and the texture that we're seeing here. Here's another one. This one is for a man, and as you can see, we have really nice detail in the forehead. Even the mustache and the beard is really nicely done. Here's another one. This one is a portrait of a woman outside, and same thing for a man. Now here's an example of landscape. This one is a nighttime city life, and you can see the reflection on the road here, since I specify that it is a rainy setting. Here's another one. You can see the natural skin texture. Another landscape, and this is the example I showed you earlier. Now you can run this locally on your machine using ComfyUI, and I will show you how to set it up on your machine. Now you need to know a little bit about the Flux model, and you will also need to have the Flux VAE and the Flux clips in order for this one to work. If you don't have any of the Flux models, check out some of my videos. I have them on the channel. It will take you explaining how to download the clip as well as the VAE models. Now, if we take a look at the workflow here, we can see that it's a simple Flux workflow. We have a load diffusion. This is the new model, the SRPO model. But when we take a look at the dual clip loader, it's exactly like the Flux. We have the T5XXL, the clip L, and then the type is Flux. The VAE is the same. We have the AE.SafeTensors, which is basically the Flux VAE. We also have the Flux guidance. That's basically your traditional Flux workflow. I'll have a link to the workflow in the description below. You can just drag and drop inside your ComfyUI. The installation process is very easy. The first thing that you'll need to make sure is that you have ComfyUI up to date. So go inside your ComfyUI portable folder, go inside the update folder. Then inside here, you're going to click on the update_ComfyUI.bat file. This will update your ComfyUI to the latest version. If you do not have the portable version, and if you have the ComfyUI application, you can go inside it. If you have the default settings, it's going to automatically update at launch time. And you will see something like this. It will probably tell you updating ComfyUI like this one. If you have a different version of ComfyUI, a manual installation, then you will need to go in and do git pull to get all the changes and update your ComfyUI that way. Now, once ComfyUI is up to date, you will run ComfyUI as you would normally do. Next, you will need the workflow and the model file. We'll go to HuggingFace page. Again, link will be in the description below. Then click on files and version. In here, you will see a folder called ComfyUI. Go inside it, and then you will get the PNG file and the .json file. So you can use any of these workflow if you have the system requirements. So if you go back here to files and versions, you can see that this default model that we have here is 47.6 gigabyte. So it's going to take quite a bit of VRAM to run this optimally. I do not have the necessary VRAM, so I'm not going to download this version. Instead, I'm going to download the quantization versions. And there's one for ComfyUI specifically. So we can see here we have two versions. We have an 8-bit and a 4-bit version. Additionally, we also have a SafeTensors version that can just drag and drop, replace the Flux.1 Dev model with this one. Now, I've tested all three of these. I will show you the result a little bit later on. To download any of these, you just need to click on the respective download buttons for the one that you want to. Now, if you're using this version, then you will download this workflow here. Now, once again, if you are downloading the Tencent version, this is the original one. The workflow you will need is inside ComfyUI and the SRPO workflow. But again, you will need that resource to run this almost 50 gigabyte model. The one I will be running is these three here, which require this workflow. So download the necessary files. Then all of the files will probably be in your downloads folder. Just need to go there, copy or cut, and we'll go inside the ComfyUI folder, inside models folder, and you need to place them in the correct folder. For the SafeTensors one, you will need to go inside the Diffusion models folder and then paste it here. As you can see, mine is here. For these two versions, the GGUF one, you'll need to go in and paste them inside the UNet folder, like so. Now, additionally, like I mentioned, you will need to have the additional models for Flux. You'll need to have your clip L and the T5XXL. I have the FP16, but there's also an FP8 version. And you will need the VAE, the AE.SafeTensors. This is traditional Flux.1 Dev workflow here. Now, for the workflow, in your downloads folder, you will have this workflow.json, as long as you've downloaded the correct version. Simply drag and drop it inside ComfyUI, and it will load the workflow. Now, some of you may get this message saying some nodes are missing. And we have this. The one that is important here is the UNet loader, GGUF. That is if you are using the GGUF version, the Q4 and Q8 bit. This empty latent by size is not necessary because you can use the default empty latent node from ComfyUI. So I'm going to close out, and there's some validation. Again, I'm going to close out. Go inside the manager, click on install missing custom nodes, and it will tell you that you are missing these nodes. Like I mentioned, this one is completely optional, but this here is the one that we are looking for. If you are going to use the GGUF version, you'll need to download this custom nodes and make sure it's by this author here. Now, I already have it. I've just disabled it for this tutorial, so I'm going to enable it. But if you don't have it, you will get an install button. Click on install, restart your ComfyUI. And once again, because I did not install the Wish custom node, I'm again getting this missing custom node. That's an easy fix. I'm going to close out of this error message and find the node. So this is the node that is missing right now. I'm going to double click on an empty space and just type in latent. I will add this empty latent image. Because this is Flux.1, you can do the default 1024 by 1024. I'm going to go with a landscape 16 by 9 aspect ratio. So I'm going to do 1280 by 720. You can use any Flux compatible aspect ratio width and height. Now connecting it is very easy. We'll remove this and then connect the latent to latent here. Okay, so make sure the empty latent image, the latent output is going into your K-sampler latent image. Now we're not done here. We need to connect it to the model sampling flux width and height. Now of course you can manually do the same here by doing the width and height as what you've inputted in here. But then if you're changing the width and height, you'll need to remember to change the width and height here as well. One easy way that you can do just by using the default ComfyUI node is take your empty latent image, the width and height. You will get a dot here when you place your cursor there. As you can see, mine appear here. I'm going to take it, drag out, close out this int, just click on the X button and then type in primitive and you should get the primitive node. Select it and add it to your workflow. You can duplicate it by pressing Alt, hold, click and drag to make a copy and then put it to height here. This way you have a primitive for the width and the height. Of course, you can double click and rename. This is going to be the width and this is going to be the height. Now, since we have these two primitive nodes here, we can connect it to the model sampling. So we'll take the width int to width here and then the height to height here. Now, when you change the value in the primitive node, it's going to update the model sampling as well as the latent image resolution. Now, some of you may get a missing node for RG3 ComfyUI custom node. Now, I already have it, but this is just a simple node for randomizing or getting a fixed seed. So if you don't want to install this custom node, it's quite heavy. You can just delete this node and you will get your seed in the K-sampler itself. Now next, make sure that your models are showing here. You can press R on your keyboard to reload the node definitions and then you should be able to select it from the drop down. By default in this workflow, the GGUF version is the one that is connected. So we can see here the connection goes to model sampling here. If you want to use the SafeTensors one, you just need to connect the load diffusion model to model sampling like this, and it will disconnect this one, the GGUF version, and you should be able to use your SafeTensors version. From my testing with all three models, the Q4, Q8, and the SafeTensors one, the differences between the models is negligible in my opinion. Now, of course, if you're doing higher resolution, maybe you are going to see some drastic changes. I've done the 1280 by 720 in all of my testing, and the results are pretty good for all three models. Now, additionally, you need to make sure that your clip is selected correctly, especially if you have different names for them. So as you can see, this one uses a capital F for Flux clip L, but mine is called clip L. So if yours is a different name, you just need to click on the clip name 1 and 2 and then select the correct version. So I'm going to select clip L. For the clip name 1, I'm going to select the T5XXL version. The type should be Flux. It should be selected by default. Now load VAE, I have the default name of AE.SafeTensors. So I'm going to select this one and I'm going to start with the Q4 version. You can keep the same prompt. I'm going to change it from girl to woman. And then I would like to point towards the K-sampler steps count. This is the inference step. And you can see here by default, it is at 50. I'm going to keep it as default and run it. All right, so it's completed and take a look at this. So once again, we are focusing on the photorealism when it comes to characters, the skin texture, and look at the skin here. It's so well defined. We have pretty much natural skin texture, and we start to question whether it's real or AI generated. And this is just the Q4 version. Let's do another one with the Q8 and then the SafeTensors one. I'm going to fast forward once I have all the results. Okay, I've done a couple of generation, and this first example is the Q4 version at 50 steps, and you can see pretty much the same. I've changed the prompt a little bit so that the character is facing forward. and we can better compare it. Same thing, we have really good detail in the skin, the hair as well. Background is blurred. Now, I've tried at different steps. So this is a 10 steps, and you can see that the image is noisy. We don't have enough steps to remove all the noise, and you can see it here. The character is not in focus actually, and the eyes, and there's just too much noise in here. So I've increased it to 20. Slightly better, but not great. Feels like there's like a noise filter applied on top of the image. So at 30 steps, in my opinion, this is where I think it's usable, especially if you are doing a lot of generation and you're trying to pick up one image from those generation. So as you can see, this one is good result. It's not quite as nice as the 50-step version, but if you're testing some prompts, it's better to use 30 steps so that you can get an idea of what the image will look like. Then once you like the base image, you can fix the seed, bump up the inference steps to 50, and then generate it again to get a higher quality. Now here's another example. This one is a man. Everything is same. The prompt, the settings, even the seed is same. The only thing I've changed woman to man, and we have this. So as you can see, the beard, the mustache, the hair is really well defined, and the face itself feels real. So here's an example of getting the base image at 30 steps and then generating the same thing for 50 steps. Here's the comparison again, 30 steps, and this is 50 steps. So as you can see, we have higher detail in the 50 steps compared to 30 steps, but the 30 steps is a good starting point in case you are generating and testing out your prompt. And here's the difference map. Ignore this. This is where I had 30 and 50 steps, so that's obviously different. This is the character here, and you can see the extra detail being added for the 50 steps. It's mainly in the hair on this side, and then the eyes and nose. We have a little bit in the mouth as well. Okay, so moving on, we have 50 steps, and this is the Q8 model. It takes an extra 10 seconds for me to generate, but in terms of changes, it's exactly the same image, at least to my eyes, unless I use that difference map again to actually see the changes. So you can see here, this is the 50 steps, and this is the Q8 version. The difference is just in the eyes, the position of the eyes and the mouth placement. Everything else to my eyes look the same. We have a little bit extra hair for the Q8 version, even though the seed and all the settings are the same. So this one, you can see the difference map here. Eyes, a little bit of hair added here, and then the nose and mouth placement is different. Otherwise, the quality of both images is pretty much the same. So that was the Q8 version, and we have the SafeTensors format. So this one is faster, at least for me. It's faster than the Q4 and Q8 at 50 steps. The quality is pretty much the same once again, at least to my eyes. So let's move on to the original Flux.1 Dev version. So this one has almost the same time as the SafeTensors format for the SRPO model, but you can see the difference here. This is original Flux.1 Dev. It has that AI look to it, but when we'll take a look at this one, it's almost real, right? So once again, Flux.1 Dev, and then the SRPO fine-tuned version of the Flux.1 Dev. So background is almost same, considering that the base model is exactly the same. So let's take these two images into the image comparison, and you can see this is a big difference. So original Flux.1 Dev and then the SRPO fine-tuned version. This has that AI look that we've seen when generating using the Flux model, as long as we're not using a LoRa on top of it, right? So this is just the basic Flux workflow without any additional model, no LoRa's. Same thing here, the original Flux workflow, just using the SRPO. This specific case is the SafeTensors format. If you use the Q4 or Q8, you will get pretty much the same result. So in my opinion, I like this one a lot. The SRPO model is really nice when it comes to generating these photorealism. That said, the original Flux.1 is not bad. It's quite good, but if you want to get away from that AI look, then SRPO may be the model for you. Now, as a fun test, I've also done one with the Flux.1 Dev Krea. I've made a video on this on the channel. This one is faster than the original Flux.1 Dev, but as you can see, the image is completely different. This Krea version is also trying to tackle getting photorealism when it comes to generating people faces. So overall, I think I like the eyes in the Krea version more compared to the SRPO version. The skin, the hair is super high quality when it comes to the SRPO version, but the eyes I've noticed, if you go up, this one is good. This one is not as detailed as I would like it to be. You can see the original Flux with the same prompt, same settings, same seed. We at least have some detail in the eyes. I think this one is better in all three comparison, but the overall image composition is not great. It seems to be having that noise filter once again for the Krea version. Even the original Flux.1 Dev is better compared to this one. But when it comes to skin, texture, and the quality itself, I think I personally prefer the SRPO version. Now going back to this Tencent SRPO HuggingFace page, there's an example here where it talks about LoRa as well. So this one here has a dev adapter LoRa weight at 0.75, and you can see the different quality that you will get here. Okay, so it works as a drag and drop replacement to your Flux model. So any workflow that utilizes the Flux.1 Dev model can be replaced with the SRPO version in case you're trying to get that realistic look to the AI generated images. All right, so that is it from me. Let me know your thoughts on this model, if you've tried it, and what are the quality that you are getting. If you reached the end of this video, I'll appreciate if you give this video a like, subscribe if you have not. I would like to shout out all of my Patreon members supporting the channel over on Patreon. Thank you to all. Have a nice day. Take care. I'm going to see you next time.